Alright, so we've made it to chapter 9. So hopefully you've gone over the first section, just kind of an overview of what we're doing. In section 2, we're looking at comparing proportions. So we've looked at an individual proportion. Individual means now we're going to be comparing them to each other. So, in this question, so we had that many occupants not wearing seatbelts, 34 were killed. Among 7,667 occupants wearing seatbelts, 13 were killed. So we have two different samples to claim that the seatbelts are effective in reducing fatalities. So we have not wearing seatbelts and wearing seatbelts. So we're kind of looking at the percentages of people that we're not wearing versus wearing to see if it's beneficial. Are the proportions the same? Are they different? Are seatbelts effective in reducing fatalities? And again, so this has given me context to how do I want to make my hypothesis test. We always know that our null hypothesis has an equal sign, so basically our proportions equal to each other. But if we look at not wearing being our first proportion and wearing being our second proportion, I want to know if seatbelts are effective in reducing. So in that case, which proportion would be greater? So that should mean that the not wearing probably has a greater fatality rate than wearing seatbelts. So the fatalities for not wearing seatbelts is be larger than not wearing. So this is what we think our alternative hypothesis is. So we want to identify the test statistic. And so when we're doing this, we have very large samples, right? We have the data here from our samples. And so when we go looking at our proportions, let's do this in StatCrunch. Again, you can do this in your TI. You can do it by the formulas that the book provides. I'm going to use StatCrunch. Proportion stats, we have two samples. And we have a summary of the information. So looking at this, I see that I had 34 that were killed out of the 2,751, and when they wore seatbelts, I had 13 that were killed out of the 7,667. Now I do want you to notice that the way that they write their hypothesis is a little different. Instead of saying that they're equal to each other, they're saying that the difference would equal 0. So that makes sense. And we said that P1 is greater than P2. So if I were to subtract P2 from P1, I would get a number that's greater than 0. A bigger number minus a smaller number would give me a positive value, some number greater than 0. And once I just put my information in, it'll spit out my test statistic and my p-value. So my test statistic is 7.16 to 2 decimal places, and my p-value is super small, just zeros to 3 decimal places. And then the conclusion I'm going to make, since my p-value is lower than this alpha, is less than the significance level. So we are going to reject the null hypothesis, say that there is sufficient evidence to support the claim that the failure rate is higher for those not wearing seatbelts. We could do a confidence interval. And so if we're at alpha is 0.05, we'll say it's a 95% confidence. If we go back in and just change it to a confidence interval, we get the following numbers, 3 decimal places, 0.006 and 0.016. 0.015. And again, just doing the confidence interval, changing that, making sure it's a 95% because our alpha was 5%. On the confidence interval, again, we don't see a 0 in it. Therefore, we'd probably reject, right? Since 0.006 is above and 0.015 is above, 0 is not within that interval, so that would also allow us to reject. Does not include 0. It appears that 2 fatality rates are not equal because the confidence interval limit includes only positive values. It appears that the fatality rate is higher for those not wearing seatbelts. One more part. Use a seatbelt. That's what the report suggests. What do the results suggest about the effectiveness of seatbelts? Use of seatbelts is lower. It's not the same and it's not higher, so it's lower. Again, we always have an opportunity for error. We rejected the null. Maybe we made a type 1 error. But many studies have been done that probably support that claim. So in this section, those are the types of problems that we're going to be dealing with. We're going to be asked to find the proportions, put our values in, do confidence intervals, but it's just mimicking that that process, but really trying to understand what we're doing. Null hypothesis would be that they're equal to each other, and the alternative is saying that one proportion is different somehow than the other.